Imagine driving toward the coast of southern China. The road is busy, trucks are moving, cars are passing, and ahead, the highway seems to be heading straight toward open water. Then the road drops. The buildings disappear behind you. The daylight fades. And within seconds, you're driving through a tunnel beneath the Pearl River Estuary. There's no dramatic moment when you realize you're underwater. Simply feels like another highway. That's what makes the Shenzhen-Zhongshan Link so fascinating. The entire route stretches about 24 kilometers across the Pearl River Estuary, connecting Shenzhen with Zhongshan. Buried inside that system is a 6.8-kilometer underwater highway tunnel carrying 8 lanes of traffic. And the strangest part is how the tunnel was built. Engineers didn't spend years simply drilling one enormous hole beneath the estuary. Instead, they built giant sections of the tunnel separately, floated them into the water, and then lowered them into a prepared trench on the riverbed. One of those sections weighed around 66,000 tons. That's an enormous structure to move through water, let alone place precisely on the bottom. And this wasn't happening in a quiet construction pond. The Pearl River Estuary is a busy waterway, with tides, currents, shipping traffic, sediment and severe weather. So the engineers had to solve a very unusual problem. How do you assemble a highway underwater while the waterway around you keeps moving? The answer starts with the location itself. Shenzhen is one of China's major technology and manufacturing centers, while Zhongshan sits on the western side of the Pearl River Estuary. For years, the water between them created a major transportation barrier. Before the new connection opened, a journey that could take around 2 hours was reduced to roughly 30 minutes once the Shenzhen-Zhongshan Link began operating in 2024. But connecting these two cities wasn't as simple as drawing the shortest route on a map. A bridge could carry traffic over the water, but parts of the estuary are used by large ships, so the route also had to work around maritime traffic. A conventional tunnel was another possibility, but digging a huge bored tunnel beneath a complicated estuary would bring its own challenges. So the final design combined several different structures: bridges, artificial islands, and an underwater tunnel. The result wasn't just one giant structure. It was an entire transportation system designed around the geography of the estuary. And this is where the construction becomes really interesting. Unlike a conventional tunnel, the underwater section wasn't built entirely underground. Instead, engineers divided it into 32 immersed tubes, along with a final closure section. Each section was essentially a giant piece of highway waiting to be installed. The engineers first had to prepare the seabed. Then they had to move each enormous tube toward its final position. Because the sections could float, the water itself became part of the transportation system. But moving a structure weighing tens of thousands of tons isn't like moving a small boat. Wind affects it. Currents affect it. Tides affect it. And once the section reaches the installation area, engineers have to control its movement with extraordinary precision. It isn't enough to get close. The tube has to reach the seabed at the correct position and orientation so it can connect with the sections already installed. One of the largest immersed sections weighed approximately 66,000 tons. Imagine watching that operation. A massive structure is floating on the water. Engineers begin controlling its descent. Slowly it moves downward. The water around it changes as the structure approaches the prepared foundation. And then it has to settle into exactly the right position. One installation required about 38 hours of continuous work. This wasn't simply a crane lowering a piece into a hole. It was a carefully controlled underwater operation involving a structure comparable in scale to a major building. And after the section reached the seabed, the job still wasn't finished. It had to connect to the next section. 2 enormous tunnel sections sitting underwater have to meet precisely. The joint has to remain watertight. The structure has to remain stable. And the finished roadway has to behave as one continuous tunnel. Once the sections are connected, The separate pieces begin to function as a single underwater highway. Eventually, traffic can move through the completed tunnel while the water above continues flowing normally. From the surface, almost none of this is visible. And that's one of the strangest things about a project like this. The final result looks simple. It's just a road. But underneath that road is a construction process that took years to complete and involved more than 10,000 workers. So why go through all this trouble? Why build giant sections, float them, sink them, and connect them underwater? Why not simply drill a tunnel through the seabed? A bored tunnel is excavated through the ground using specialized equipment. An immersed tunnel takes almost the opposite approach. You build the tunnel first, then take it to the water. That changes the entire construction process. Instead of asking a giant machine to excavate several kilometers beneath the estuary, engineers can manufacture the tunnel sections in a controlled environment, transport them by water, and install them one by one. It's a completely different way of solving the same problem. And in this case, it allowed engineers to create one of the most ambitious underwater highway projects ever attempted. But putting the tunnel on the seabed was only half the battle. Because once you have a highway beneath the water, you still need to make it safe for ordinary people to drive through. And that's where the tunnel becomes much more than a giant concrete tube. Because the road you see inside it is only one layer of the system. And beneath that road is an entire hidden network keeping the tunnel alive. The tunnel is finally sitting beneath the water. But now comes a different problem. How do you turn a giant underwater structure into a highway that thousands of people can safely use every day? Because drivers aren't supposed to think about the engineering. They shouldn't be wondering whether the tunnel is moving. They shouldn't be worrying about water pressure. And they certainly shouldn't be thinking about the thousands of tons of concrete above the seabed. They should simply see a road and keep driving. That's why the systems inside the tunnel matter just as much as the tunnel itself. The completed underwater section stretches for about 6.8 kilometers. But inside that space is far more than pavement and lights. There are power systems, drainage, communications, ventilation, fire protection, and monitoring equipment working together behind the walls. Much of it is completely invisible to drivers. One of the most interesting features is a central pipe gallery running through the tunnel. Carries cables and pipes that support the infrastructure around the roadway. Project officials say the tunnel contains more than 10,000 sets of equipment. So while a driver sees a clean highway, behind the walls is an entire mechanical network. And that network has to keep working continuously. Because an underwater tunnel doesn't get a second chance if something goes wrong. Water is the obvious danger. But fire can be just as serious. A vehicle fire inside a long tunnel can quickly fill the space with smoke, making it difficult for drivers to see where to go. So engineers developed a specialized smoke exhaust system for the underwater section. According to project information, the system improved smoke exhaust efficiency by about 42%. The idea is simple. If an emergency happens, the tunnel needs to control the environment quickly enough to give people time to leave safely. Even the lighting is designed with emergencies in mind. Under normal conditions, the tunnel has the kind of lighting you'd expect on a modern highway. But in an emergency, different lighting signals can help direct drivers and pedestrians toward safer routes. It's a small detail. But underground, small details can make a huge difference. Then there's another problem people rarely think about. Communication. You're driving several kilometers beneath the water. Yet your phone can still connect. The tunnel includes 5G communication infrastructure designed to maintain connectivity along the route. That means the tunnel isn't isolated from the outside world. Traffic control systems can communicate with the tunnel. Emergency services can communicate with people inside. And drivers can remain connected while traveling beneath the estuary. But the most unusual part of the system may be the machines watching everything. The tunnel uses intelligent inspection robots to monitor infrastructure. These machines can move through areas that aren't convenient for human workers and help identify problems before they become serious. They can inspect equipment, collect information, and send images back to the control center. So imagine what is happening during an ordinary drive. You're sitting in your car, listening to music, maybe talking to someone. You see nothing unusual. But around you, sensors and machines are constantly monitoring the tunnel. The goal isn't to make the tunnel look futuristic. It's to make the technology disappear into the background. And that's exactly what good infrastructure is supposed to do. But there is still one enormous problem that the technology can't hide. The tunnel is sitting beneath a huge body of water. Every square meter of its structure has to deal with the forces created by that water. And the deeper the tunnel goes, the more serious that problem becomes. Parts of the Shenzhen Zhongshan underwater tunnel are nearly 40 meters below the water surface. So while you're driving along a perfectly ordinary highway, there can be tens of meters of water above you. You don't see it. You don't feel it. But the structure is carrying that environment every second. And then there's seawater itself. Salt and moisture are extremely unfriendly to infrastructure over long periods of time. This isn't a bridge that only has to survive wind and rain. The tunnel has to remain protected from a constantly wet, corrosive environment. That's why the project was designed with a service life of more than 100 years. The engineers weren't building something for today's traffic alone. They were building something that would have to keep working for generations. And the tunnel isn't the only unusual structure in the middle of this project. To connect the underwater section with the rest of the highway, engineers also built artificial islands. These islands act as transition points between the underwater tunnel and the roads and bridges around it. From above, they look like pieces of land surrounded by water. But they're actually part of the transportation system. And this is where the entire design starts to make sense. The project doesn't force the road to stay above the water. And it doesn't force the road to stay below it. It uses both. Where a bridge makes sense, the highway rises above the water. Where going underneath is more practical, the road dives below it. Artificial islands connect the different sections. The result is a continuous route across the Pearl River Estuary. And after years of construction, the system was finally ready. On June 30, 2024, the Shenzhen Zhongshan Link opened to traffic. For drivers, the experience was surprisingly ordinary. They simply entered the highway, drove across the estuary, passed through the underwater section, and continued toward the other side. But beneath their tires was one of the most complicated parts of the entire project. A highway built inside enormous structures, resting on the seabed, with the river moving above it. And that raises the bigger question. Why was China willing to build something this complicated in the first place? Because the answer isn't really about building a tunnel. It's about changing how an entire region connects. The real reason for building this project becomes clearer when you look at the map. Shenzhen and Zhongshan aren't separated by a small stretch of water. They're part of a much larger economic region around the Pearl River Estuary, where cities, factories, ports, and businesses are constantly moving people and goods. For years, the water created a natural barrier between the eastern and western sides of the estuary. The Shenzhen-Zhongshan Link changes that relationship. A journey that could take roughly 2 hours can now be completed in around 30 minutes. That difference matters. For commuters, it means less time on the road. For businesses, it means faster movement between cities. And for the region as a whole, it creates another direct connection across the estuary. But the road itself isn't the only impressive part. The entire link stretches about 24 kilometers and combines bridges, artificial islands, and the underwater tunnel into one continuous route. That combination is important because the Pearl River Estuary isn't the same everywhere. Some areas are better suited to bridges. Others create conditions where going underneath makes more sense. Instead of forcing one solution across the entire route, Engineers used different structures for different sections. And that's one of the most interesting lessons from this project. Good engineering isn't always about finding one perfect technology. Sometimes it's about combining several technologies and making them work together. The bridges carry traffic above the water. The artificial islands provide transitions. And the immersed tunnel handles the section where going underneath becomes the better option. But building all of these structures together created another challenge. The project had to exist in an environment that was already extremely busy. Ships were still moving through the estuary. The tides didn't stop. The weather didn't stop. And the water didn't become calm just because construction was happening. More than 10,000 workers were involved during the 7-year construction period. For them, the construction site wasn't simply a piece of land surrounded by a fence. It was spread across the water. Some work happened on artificial islands. Some happened at specialized construction facilities. And some of the most critical operations happened directly on the water. Every tunnel section had to reach the correct location. Every connection had to line up. Every system had to be tested. And eventually, the entire route had to work as one highway. Then came the moment when all of that engineering became invisible. The road opened. Cars began moving through the system. And something remarkable happened. The drivers didn't see the years of construction. They didn't see the 66,000-ton tunnel sections. They didn't see the underwater foundation. They didn't see the robots or the equipment hidden behind the walls. They simply saw a highway. That's the strange thing about major infrastructure. When it works perfectly, it can look almost boring. A driver enters. The road continues. The tunnel appears. The tunnel ends. And the driver keeps going. But underneath that ordinary experience is a structure designed to deal with water, pressure, corrosion, traffic, and emergencies for decades. And there's another reason this project is so interesting. Changes the way people think about distance. A body of water that once represented a major obstacle becomes something you can cross almost without noticing. You don't have to wait for a ferry. You don't have to follow a long detour. You don't have to think about the water at all. You simply drive. And that's the real purpose of the project. Not to create the world's most dramatic tunnel. Not to build something that looks impressive from the air. But to make two parts of a major economic region feel closer together. The engineering disappears into the background. And the connection becomes normal. But there's still one final thing worth understanding. The tunnel isn't impressive simply because it's underwater. Its real achievement is that thousands of tons of concrete and steel, dozens of massive tunnel sections, bridges, artificial islands, and thousands of pieces of equipment all have to work together. Every single day. If one system fails, another has to respond. If an emergency happens, people need a safe way out. If equipment starts behaving differently, monitoring systems need to detect it. And if the structure is going to remain in service for more than a century, those systems have to keep evolving with it. So the biggest achievement isn't actually the moment when the tunnel disappeared beneath the water. It's everything that happens afterward. Every car that passes through without thinking about what's above it. Every truck carrying goods across the region. Every commuter who saves more than an hour on the journey. That's when you realize what this project really accomplished. It didn't conquer the ocean. It didn't remove the water. It simply found a way to make the water irrelevant to the journey. And that is what makes the Shenzhen-Zhongshan Link more than just an underwater tunnel. It's a new connection between two sides of the Pearl River Estuary. And for the people using it, the most extraordinary part may be how ordinary it feels. Now imagine making the same journey yourself. You approach the Shenzhen-Zhongshan Link. The road stretches ahead. Traffic is moving normally. Nothing about the scene tells you that one of the most complicated parts of the route is waiting just ahead. Then the highway begins to descend. The sky disappears. The daylight fades. And the road carries you beneath the Pearl River Estuary. For a few minutes, you're surrounded by concrete walls and artificial lighting. You can't see the water. You can't see the ships above. You can't even really feel that you're underground. You just keep driving. And that's exactly what the engineers wanted. The technology is supposed to disappear. The structure is supposed to feel ordinary. Because if you're driving through a tunnel and thinking about the tunnel every second, something has probably gone wrong. A successful piece of infrastructure becomes part of everyday life. People stop asking how it works. They simply use it. And that's what makes this project so interesting. From the outside, it looks like a collection of bridges, islands, and roads. But underneath that appearance is a much more complicated story. Engineers had to design enormous tunnel sections. They had to transport them through a working waterway. They had to lower them onto the seabed. They had to connect them underwater. Then they had to build all the systems required to keep the finished highway safe. And finally, they had to make all of it disappear into the background. The result is a 24-kilometer connection between Shenzhen and Zhongshan. Inside it is a 6.8-kilometer underwater highway tunnel. And when traffic is moving through it, almost none of that engineering is visible. That's perhaps the best way to understand a megaproject. Don't judge it only by how impressive it looks. Look at what it changes. Before this connection existed, crossing between these parts of the Pearl River Estuary could take much longer. Now, the journey can be completed in roughly 30 minutes. Commuter gets home earlier. A truck reaches its destination faster. A business can connect with another city more easily. And millions of ordinary journeys can happen without anyone thinking about the engineering underneath them. That's the payoff. Not a spectacular moment. Not a giant machine. Just time save. Every day. And there is something almost strange about that. Thousands of workers spent years creating something that most drivers will barely notice. They built structures weighing tens of thousands of tons. They worked around tides, ships, and severe weather. They installed systems that drivers will never see. They created a highway beneath the water, so that everyone else could forget the water was there. That's what great engineering often looks like. The difficult part happens behind the scenes. The final experience is simple. You enter, you drive, you emerge on the other side, and suddenly, the cities that once felt separated by the estuary feel much closer. The tunnel didn't make the ocean disappear. It didn't change the geography. It simply gave people another way through it. And maybe that's the most impressive part of the Shenzhen-Zhongshan Link. Engineers didn't try to defeat the water. They designed around it. They studied its movement. They worked with its constraints. And eventually, they turned an obstacle into a route. So the next time you see a highway disappearing beneath the water, remember what is actually happening. There may be tens of meters of water above you. There may be thousands of tons of concrete around you. There may be an entire network of cables, pipes, sensors, and machines working behind the walls. And yet, inside your car, feels completely normal. You simply follow the road and keep going. Because sometimes the greatest engineering achievement isn't building something that looks impossible. It's building something that makes the impossible feel ordinary.